All right, today we're diving into something pretty incredible, SAM 2. This is the next giant leap in how AI actually sees the world. So if you thought AI vision was impressive before, just wait till you see what happens when it learns to see things in motion.
So, cast your mind back to last year. The original Segment Anything model, SAM, just exploded onto the scene, right? It was a total game changer. It gave AI this almost magical power to look at a photo, any photo, and with just a click, it could perfectly outline every single object in it.
But here's the thing. The real world isn't a static photograph, is it? It's messy. It's a nonstop stream of movement and change. So that immediately led to the big, obvious question, what happens when the subject doesn't just sit still for the camera?
And that, right there, is the leap we're talking about. We're going from single pictures to full-on movies. And believe me, this isn't just a small step up. It's a completely different ballgame for how these AI vision systems have to think. The original SAM was brilliant, no doubt, but when you showed it a video, it kind of had amnesia. It could analyze each frame perfectly, one by one, but it had zero idea that they were connected. It's like looking at a flip book by staring at each page individually without ever actually flipping them to see the animation. So yeah, that created a massive technical problem. Moving from one clean, high-res photo to a constant video stream, well, that introduces a whole bunch of new challenges that an AI has to solve on the fly in real time. I mean, why is this so much harder? Well, just think about any video you've ever watched. Objects are constantly getting blocked by other things. That's called occlusion. They bend and change shape as they move, deformation. The camera itself is moving, the objects are moving, creating all this motion blur. On top of that, the lighting can change in a split second, and honestly, video frames are usually way lower quality than a nice, crisp photo. And this is exactly where SAM 2 enters the picture. The researchers at Metafair decided to tackle all of this with one core, brilliant idea. They gave the AI a memory.
And having that memory allows SAM 2 to create something totally new. It doesn't just make a mask for an object on a single frame anymore. Instead, it creates what's called a masklet. The easiest way to think about this is as an object's outline that doesn't just exist in space, but it persists through time across a whole bunch of frames.
So how does it actually remember? It's all thanks to this really clever four-step loop. Okay, so first, an encoder looks at the current frame. Then, and this is the magic part, a memory attention module checks a memory bank of the last few frames to get some context. Then, it predicts where the object is now, and finally, it stores that new prediction back into the memory bank to help with the next frame. It's this continuous loop of seeing, remembering, and predicting.
But a smart model is pretty useless without tons of great data. And the way they built the dataset for SAM 2, well, it's a revolution all on its own. They basically created a data engine where the AI actually helped teach itself to get smarter.
It all happened in 3 stages. In the beginning, it was super slow. You had humans using the old SAM to label every single frame. Then they brought in an early version of SAM 2, and it started helping out by guessing where the object would be in the next frame. That made things a lot faster. But in the final phase, the full, powerful SAM 2 model was part of the team, letting human annotators just make tiny corrections with a click here and there. It was unbelievably efficient.
And the results from this data engine are just wild. At the start, it took a person almost 38 seconds to label one frame of video. By the end, with the full SAM 2 model helping out, that time plummeted to just 4.5 seconds. That is an 8.4 times speed up. It's a huge leap that let them build a dataset on a scale nobody had ever seen before.
And what a scale it is. The final dataset, SAV, has 35.5 million individual object masks. To put that in perspective, that's 53 times more masks than any other video segmentation dataset out there. It's just a colossal amount of data to learn from. So you've got a much smarter model architecture and a way, way bigger dataset. The obvious question is, how good is it really? Well, the performance numbers are, to put it lightly, pretty darn impressive. And check this out. This might be the most surprising part of the whole thing. SAM 2 isn't just better at video. They tested it against the original SAM on its home turf, just plain old still images. And not only was it more accurate, it was an insane 6 times faster. It got so good at understanding motion that it just got better at everything. And when you bring it back to video, that efficiency really shines. If you compare it to the old way of doing things, like trying to duct tape the original SAM to a separate tracking program, SAM 2 gets you a better result with 3 times fewer clicks and corrections from a person. It just works.
The researchers themselves said it best. They didn't see this as just a small improvement. In their paper, they called it a step change, saying it fundamentally alters what it's like to work with video segmentation.
Okay, so let's step back for a second. What does all of this actually mean for the future? Why is teaching an AI to truly see in motion such a big deal?
Well, the potential applications are just huge. Think about augmented reality, where you can have digital objects interact perfectly with the real world. Or for robotics and self-driving cars, this gives them a much deeper, more persistent understanding of what's happening around them. We could see crazy powerful new video editing tools, faster scientific analysis of things like medical scans, and it could even power new kinds of generative AI.
So there you have it. We've basically given AI a powerful new sense, the ability to see and track pretty much any object through time and space. So the only real question left to ask is, what are we going to ask it to see next? What new frontiers is this going to unlock? Thanks for tuning in for this explainer.